Welcome to another present here. And today we are going to see about a session on the aircraft manufacturing technology, specifically on the Unit 4 conventional and non-conventional machining process with the topic of conventional machining with the lathe and shaper machines. I'm excited to make a review of the principles, core concept, and the timeless tools remain in vital in the precision engineering. And we can see the fundamentals with the real world insights, including a quick quiz to keep the things sharp and to be clear. And this is Shoram Gesh, Assistant Professor from the Department of Aerospace Engineering, SNS College of Technology. So today's topic for the discussion is that to explore the principles of conventional machining, which is focused on the lathe and the shaper, and which is exactly on the conventional machine, and then to drive into the core concepts of the lathe machine and the shaper machine, and by the end we can see the how it works with the of the backbone of the metalworking in the aerospace beyond. And next slide is the principles of conventional machining. So conventional machining is all about the mastering precision metalworking through the reliable time-tested tools. And the picture is described as the manual control with the skills operated, guided through the lathes and the shapers with expert precision and no automation needed. It's perfect for the low volume excellence and using sharp single tool cuttings for the specialized jobs. Unlike CNC's computer-driven world, and this relies on operator expertise, bending hands-on skill with the mechanical powers, as we see in the slides visual. It is the foundation of the craftsmanship that empowers everything from the aircraft parts to the prototype. So next is we enter into the lathe and shaper, which will be in design thinking and define. So, shifting perspectives in conventional lathe work, operators must master cutting speeds, feed rates, and the tool angles through years of practice. Through design thinking, we reframe it as a redesign interfaces, tooling and picturing to ease the muscle memory burden. And for the shaper machine, it's a classic view and it is a slow return stroke, idling away time. Design thinking flips it has the reimagined workflows to amplify its linear cutting strength, and this defense stage in the DT, that is a design thinking, help us to reframe the problems for innovation and the key in aerospace manufacturing. And the next slide is the lathe machine core concept. So entering the lathe conceptual design, the king it is the king of the rotational precision. It spins the workpiece against a stationary tool for the spot on a cylindrical machining. Versatile, including turning for smooth cylinders, facing for flatheads, and grooving and threading for details, plus tapering and parting. The tool guides linearly, parallel and perpendicular to the axis, and for the tailoring cuts. The image shows up upon the turbine shaft. That slice diagram shows how the rotation meets the precision head on. And the next one is lathe key components and functions. Breaking down the lathe, the machine bed, the rigid cast iron base with the guide weights ensure a rock solid stability. Headstock assembly powers the spindle with the gears and the speed control, and the tailstock supports the workpiece end and to handle drills or taps. Finally, the carriage and the tool post manages the feed and the positioning longitudinally or crosswise. These components are illustrated here and turn raw stock into aerospace grade components and unwavering accuracy. So then the next one is the shaper machine. Now the shaper is it is a master of linear cutting actions. Single point tool replicates the linearly while the two workpiece sit, sits steady on a adjustable table. It's specialized for a flat surface, grooves, slots, internal keyways, and even angular counters. In aircraft assembly, these thin keyways for gears, it's set up for axles where flats slot rules. And next one is shaper key components and operations. Shapers essentials are the ram assembly drives for the forward cut and backward ideal stroke for the metal removal. Tool head with a clapper box holds a cutter, lifting it on the return to avoid scratches and prolong life. The table and the saddle system positions the workpiece with the lateral and the vertical twists. And the quick mechanism which we gets into this topic, it gives a speed up for the non-cutting stroke and slashing circle times. And the next one is the comparing the lathe and the shaper, which gives the key differences. So side by side, when we take up the lathe features, rotational workpiece with a linear tool for cylindrical, conical, or a grooved surface, which will be a continuous action for the shaft and pulley. When we take up the shaper machine, it is a reciprocating linear tool on a stationary stock for flats, slots, and keyways, intermediate forward cuts. As the table shows, the lathe for the curves, shape, and the shaper machine is for the straights. So the below image gives a clear cutout how and what are the types of the lathe operations goes on and how the shaper operations goes on. So next one is why master conventional machining. So it is for the foundation of a precision metalworking and a rapid prototype, which is crucial for the quality of craftsmanship and empowers engineers with the superior control, whether we are a mechanist or a designer. This knowledge drives professional excellence in the manufacturing. And this will be the mind map which we comes under for the conventional machining. So we take about the empathize and the ideate. So when we come up for the ideate, so it gives a brainstorm creative solutions. So how we are going to work on a shaper and the lathe. And the next slide is the quiz time. So it in first in the define stage, the core principle differentiates the shaper from the lathe, and the option is A, which is a quick return mechanism leads to screw for the precision leads, shear deformation, and the wide range of materials. So with these options, we take about the option A as a quick return mechanism. And the second question is, during the lathe prototyping, what specific surface finish quality metric is mentioned as targeting for testing feed mechanisms? So it for the option D as a surface finish for and these are the two options. And we take about the reference. The first reference gives about what the lathe and how it works out. And the second reference gives about the shaper machine. And the third one gives of the difference and the working principles between the lathe and the shaper machine. So we have covered the main topic of the conventional machining between how lathe rotation to as shaper strokes. So thank you for watching this video. Thank you.